Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the cross correlation function and jointly WSS or not. This is the previous examination question. The example is two random process x of t and y of t are defined as x of t is equal a cos of omega naught t plus b sin omega naught t, and second random process y of t is equal b cos omega naught t minus a sin omega naught t. Here capital A and capital B are uncorrelated, zero mean random variables with same variance omega naught is constant. First bit, determine the cross correlation function, and second bit, check x of t, y of t are jointly WSS or not. Coming to the solution, given that the two random processes are x of t is a cos of omega naught t plus b sin omega naught t, and the second random process y of t is b cos of omega naught t minus a sin omega naught t. So now here omega naught is a constant value, capital A and capital B are the random variables that are uncorrelated random variables, and also given that the random variables A and B are the zero mean value and same variance. So that means expectation of A is equal to 0 and expectation of B is equal to 0. So given that capital A and capital B are of the zero mean, that means expectation of A is equal to 0 and expectation of B is equal to 0. And expectation of AB, and given that A and B are the uncorrelated random variables. Uncorrelated random variables mean that is statistically independent random variable. So expectation of AB is equal to expectation of A into expectation of B. So now we are given that expectation of A is 0 and expectation of B is 0, then expectation of AB is also 0. And also given that capital A and capital B are of the same variance. That means sigma A square is equal to sigma B square, and variance of the A is sigma A square, variance of the B is sigma B square. Sigma A square is also denoted as expectation of A square, sigma B square is also denoted as expectation of B square. So the two random variables are of the same variance. That means sigma A square is equal to sigma B square. And also given that A and B are the uncorrelated random variables. So uncorrelated random variables mean the correlation coefficient is equal to 0. So this is the equation of the correlation coefficient, covariance of A comma B by sigma A sigma B. But we know that covariance of A comma B is equal to covariance of A comma B is expectation of A minus expectation of AB minus expectation of A into expectation of B. So this is the equation of covariance of A comma B. So now here from the given data, expectation of A, expectation of B is 0 and expectation of AB is 0, and the numerator term covariance of A comma B is also 0. So 0 by sigma A into sigma B, 0. So the correlation coefficient, um, covariance of A comma B is equal to 0 and the correlation coefficient is equal to 0 from the given data. Once again, so given that capital A and capital B are the uncorrelated random variables, that uncorrelated random variables mean the correlation coefficient rho is equal to 0. In this equation substitute rho is equal to 0, we get covariance of A comma B is equal to 0. That is the one way of the explanation. And another way of explanation is, so using covariance of A comma B is equal expectation of AB minus expectation of A into expectation of B. So using this expression also, covariance of AB is also 0. And first bit solution, first find out the mean value of the expectation of mean value of x of t. So expectation of x of t is equal, given that x of t is a cos omega naught t plus b sin omega naught t. Here omega naught is the constant, so cos of omega naught t and sin of omega naught t is the constant. So using expectation property, expectation of sum of random variables is equal to sum of their individual expectation. So the RHS term is expectation of A into cos omega naught t plus expectation of B into sin omega naught t. From the given that Expectation of A is 0 and expectation of B is 0. 0 into cos omega naught t plus 0 into sin omega naught t is 0. So expectation of x of t is equal to 0. So now here in this equation, the mean of the random process x of t is independent of time t or constant value. Hence the given random process x of t is a stationary random process. Similarly calculate the mean value of the random process y of t. Expectation of y of t is equal, given that y of t is b cos omega naught t minus a sin omega naught t. Now here omega naught is the constant, b and a are the random variables. Using expectation property, the RHS term is expectation of b into cos of omega naught t minus expectation of a into sin of omega naught t. From the given data, given that expectation of A value is 0 and expectation of B value is 0, so which is equal 0 into cos omega naught t minus 0 into sin omega naught t is 0. So expectation of y of t is equal to 0. The mean of the random process y of t is also independent of time t or constant function. Hence, the given random process y of t is a stationary random process. Next, find out the cross correlation function of x of t and y of t. And this is the expression of cross correlation function of x of t and y of t. That is Rxy of tau is equal to expectation of x of t, y of t plus tau. Given that x of t and y of t are there and substitute x of t and y of t values here. Y of t is there, y of t plus tau is in the given data in y of t expression t is substituted by t plus tau. We get y of t plus tau expression. Therefore, expectation of x of t is a cos omega naught t plus b sin omega naught t into y of t plus tau is b cos of omega naught t plus omega tau minus a sin omega naught t plus omega tau. Now we are multiplying these two terms. We get RHS term is expectation of AB cos of omega naught t cos of omega naught t plus omega tau minus a square cos of omega naught t sin of omega naught t plus omega tau plus b square sin of omega naught t cos of omega naught t plus omega naught tau plus into minus ab sin of omega naught t sin of omega naught t plus omega naught tau, so which is equal Rxy of tau is equal on RHS side applying the expectation property. Here a and b are the random variables. Rxy of tau is equal minus expectation of a square cos of omega naught t sin of omega naught t plus omega naught tau plus expectation of ab cos of omega naught t cos of omega naught t plus omega naught tau plus expectation of b square sin of omega naught t cos of omega naught t plus omega naught tau minus expectation of ab sin of omega naught t sin of omega naught t plus omega naught tau. So now applying the given data in this equation, given that expectation of A and expectation of B is 0, then expectation of AB is also 0, and also given that expectation of A square is equal to expectation of B square. Applying the given data, the second term and third term is 0, and fourth term, in the fourth term substitute expectation of B square is equal to expectation of A square. And after substituting expectation of b square is equal to expectation of a square and this first term and fourth term take the common expectation of a square. Therefore, expectation of a square into sin of omega naught t cos of omega naught t plus omega naught tau minus cos of omega naught t sin of omega naught t plus omega naught tau. So this within the bracket term is sin a cos b minus cos a sin b is sin of a minus b. So therefore, expectation of a square is equal sin of omega naught t plus omega naught t sin of a plus b. So this is the a value and this is the b value. So sin of omega naught t plus omega naught 2 minus omega naught t. Now here plus omega naught t minus omega naught t is the cancel. The remaining RHS term is expectation of a square into sin of omega naught tau. So now here the cross correlation function of the random process x of t and y of t is independent of time t or depends on tau. Hence, the given random process x of t and y of t are jointly Whiteson's stationary random process.